Let's start the chapter periodic table. Some historical development of periodic table. Pioneers in periodic table research, most prominent Mendeleev, first comprehensive organization of element, used 32 out of 61 known elements, emphasized periodic patterns in element properties, left gaps for undiscovered elements, predicted properties of unknown elements. Some women's contribution to element discovery as well. We can see here this history just for your information, not important for exam perspective. Next, we have noble gases, group 8. So, key characteristics here are these are important to remember for exam perspective. Unique properties include extremely low reactivity, monoatomic gases, stable electron configuration, and comprise of about 1% of Earth atmosphere. Discovery and isolation of these group: argon discovered in 1894, helium first detected through solar spectroscopy, Sir William isolated noble gases in 1890, and radon was the last noble gas that was purified in 1909. Practical applications: important: helium used in airships and balloons, argon fills incandescent light bulbs, and neon used in color advertising lights. Trends in periodic table very important to remember and to understand. Metallic to non-metallic transition. Period 3 example: from sodium to argon, there is a gradual change in physical properties. Transition centered around silicon. Shift from metallic to non-metallic characteristics. Oxide characteristics: metal oxide, they are generally basic, and non-metal oxide, they are generally acidic. Bonding transition progression across period. There is metallic bonding, giant covalent structures, and simple molecular structures as well. For transition element, what are their characteristics? Important. They are located in the center block of periodic table, less reactive than group 1 and 2 metals, excellent corrosion resistance, high melting points, versatile and widely used in everyday objects. Some notable example here is chromium, corrosion resistant, tungsten, extremely high melting point, used in steel, cutlery, electronic components and tools. Now, let's talk about electronic configurations. Noble gas stability, electronic configuration, energetically stable. Other elements react to achieve similar configurations. Group 1 and 7 elements are particularly reactive. Periodic table trends: atomic size, you see the trend decreasing across periods. For example, sodium to argon. Reactivity decreases through noble gases, group 1 to group 8. Then bonding type, metallic to covalent, period 3 elements. Now, periodic table has some historical context such as Mendeleev we discussed before. They have some arranged order in increasing proton atomic number. This is important to remember. Then some key structural components like groups. Vertical columns of elements in periodic table are called as groups. Elements in same group have similar chemical properties, share same number of outer shell electrons. That's why they were all placed into the same group because of the similar characteristics. Then periods, they are the horizontal rows of elements in the periodic table. Elements in same period have increasing atomic number. Classification of elements, some major element categories. Main group elements are from 1 to 8. Then there are some transition elements in periodic table. Some are metalloids and also noble gases are there. Now, distinguish features between metals and non-meat metals. Metals located on the left or center of the periodic table. They are generally good conductors, typically solid at room temperature. Then we have non-metals. They are located in the top right region. They are poor conductors and can exist in various states. Let's talk about metalloids. Their unique properties are they are intermediate characteristics between metal and non-metals. Often look like metals but are brittle. Excellent semiconductors. The example is silicon. Next, we have spatial element group reactivity trends. Most reactive group 1 are alkali metals and group 7 are halogens. Least reactive is group 8, which are noble gases. Important point to remember, okay? Then we have hydrogen's unique position. It is difficult to categorize, often placed separately in periodic table. You will see later that there are isotopes of hydrogen. That's why it has a unique position. Then does not consistently fit into any specific group. Some key characteristics of the group 1 are alkali metal, highly reactive. An example is sodium, lithium, potassium. Group 7 are the halogens, very reactive. Example is chlorine, bromine, iodine. Group 8 are noble gases, extremely reactive, such as helium, neon, and argon. Some key terminologies to remember: proton number are the fundamental organizing principle for each atom. Electron shell, it determines the chemical behavior. Atomic mass, additional element identifier. Oxidation state, particularly important for transition metals. Now, the group 1 periodic table, alkali metals. The key characteristics are physical properties. They are soft, solid, important to remember. Okay. Group 1 alkali metals, physical properties. Soft, solid, low melting point, low density, highly reactive, quickly tarnish when exposed to air. Trends down the group. What are the trends down the group? They have decreasing properties. Decreasing properties of melting points decreases, boiling points decreases, metal hardness decreasing. What are the increasing properties down the group? Density kept on increasing, chemical reactivity keeps on increasing. Now, water reaction observation. All group 1 metals react with cold water and produce hydrogen gas. Learn it. Important. Alkali metals hydroxide solution. Reaction intensity varies from lithium, which is slow, to cesium, which is explosive. Unique fact about francium: highly radioactive, extremely rare, half life of about 5 minutes only, estimated global quantity 30 gram, at any moment it is present. Some general characteristics of halogens also very important for examination perspective. Common properties: they are poisonous, have strong smells, and they are non-metals. They are diatomic molecules, valency of 1, and form similar hydrogen compounds. Now, reactivity trends. So, decreasing reactivity, we discussed it that it is down the group. Physical state change from gas to liquid to solid. Color intensity increases. Then chemical reactivity, fluorine to chlorine, they are very extremely reactive. It reacts strongly with metals and non-metals both. They form halides and they are the oxidizing agent. Now, halogen displacement reactions. These are more reactive halogens displace less reactive ones. Example, chlorine can displace bromine and iodine from salt solution. With this, we have finished our chapter. See you in our next chapter.